Welcome to Lesson 6.5, Percent of Change. This is the worksheet that comes from the extra practice pages in Math and Focus. This is actually from our 6th grade curriculum, or actually our 6th grade course book, but we are covering this in 7th grade math currently. So our 7th grade math students are expected to be able to master this concept. It's going to appear on our 7th grade math test over percent, coming up pretty soon here. So we want you to be able to apply one of two strategies. If you look back at your percent flip book, so I'm referencing that flip book or those notes that we take together in class each day. In the percent flip book, today we talked about going from a fraction to a percent. So this will work out really well if I know both quantities. That will help me write a fraction and turn it into a percent really quickly. Or the other method of doing this is percent proportion. And if you remember correctly, percent proportion is pretty flexible. It will work for almost any problem, at least to get me an initial start. And then sometimes I have to consider whether we're increasing or decreasing. I might have to answer the question kind of carefully, but that percent proportion will also work. Notice in percent proportion, I might know a quantity and a percent. And in this fraction to percent method, I have to know two quantities. I have to know both of them in order to try that method. Let's take a look at number one. Anna makes $120 each month to sell. This month, she increases the number of dolls she makes by 30%. How many dolls does Anna make this month? Well, I notice a couple of things. Number one, I notice that we have $120. That's a quantity. It's not a percent, it's just a number value, right? With a label, it's $120. I also notice that there's this 30% sitting here. Notice again, this is a percentage. So this is already kind of leading me towards the second strategy. I'm already thinking percent proportion might be a good way to go. It also mentions in here, just as I grab important information, this month she increases the number of dolls. So this idea of an increase, I'm going to kind of highlight and remind myself with an upwards arrow. I'm looking for a percent increase, meaning the number value is going to grow. And when I go to answer this, how many dolls does Anna make this month? I'm going to look for a total number. How many dolls is talking about a total number of dolls when I'm ready or when I'm done. So thinking again about percent proportion, because I'm given a quantity and a percent. Well, if you remember this strategy or this method, we always have 100 in the lower right or in the second denominator. I also need to use this 120 dolls as my quantity. Well, that's how much she sold originally. So the original number, the original total, goes in the bottom left, meaning $120 is really the same as 100%. These align, these make sense, okay, that they would go together. The next thing I want to think about is this idea that she increases the number of dolls she makes by 30%. Well, maybe if we were to picture this real quickly, just a quick bar model. The total number of dolls right now is 120, and that's the same as that 100%. But she's going to increase the number of dolls she's making. She's going to increase that by 30%. And in a moment, I'll be able to tell you how many total dolls she was able to make. The total here. Well, I like this bar model for a couple of reasons. I could grab this 30% and plop it right here in the percentage. Another way I could think of this is this total bracket. The total bar plus the increase would give me 130%. 100% plus 30%, 130. So I might use that because I know in a minute I'm trying to answer a total. So I might put the total percent here. You can be flexible and do that, or you could just put 30% here, and when you're done, you'll have to add it on to show an increase. Well, the unknown piece then is sitting here, the numerator. I don't know what part of 120 those dolls represent. Okay? So let's go ahead and use what we've learned from this percent proportion. I encourage you to look left, look right before you cross the street. Well, if you look left here, there's nothing to simplify in the left-hand side. But in the right fraction, I notice both these numbers divide by 10. That's going to kind of eliminate the 0 that's sitting back here. 130 divided by 10 is 13. 100 divided by 10 is 10. We are ready to look at cross products next. So I always choose to multiply here with my variable term first. So I circled here first for you, what is 10 times x? And the answer here would be 10x. And remember, we set our cross products equivalent to each other. They are equal to each other. So next I have this 120 times 13. Unfortunately, I don't know that fact off the top of my head, but I am thinking I know 12 times 12 is 144, and this is 13 times 12, so I'll need an extra group of 12 in here, 156. And if you notice, I have a 0 at the back, so I should end up with 1,560. You can double check that if you like. You can stack them up and make sure that this works out, but I believe I'm heading in the right direction. And if you remember, we need to isolate the variable. We get the king alone. So secretly what's happening here? Multiplication. To undo multiplication, we use the opposite. I'm going to show that with this division. This fraction bar means let's divide, and we're going to divide by 10. Because I know 10 tenths is going to get me to just one nice variable, one nice king in a minute. If we do this to the left, we also show this on the right. Well, if I go ahead and simplify here for you, 10 tenths is the same as one whole king, or one whole variable. We bring down the drawbridge, also known as the equal sign, to keep everybody safe. The king likes to be separate from the constants. And over here, 10 does divide into this nicely. In fact, it's going to move my decimal one place to the left. Looks like I'm going to get an answer of 156. Well, we need to plug this back in and also make sure it makes sense. So over here, is it possible that 156 belongs with this unknown? Is it possible that the original 100% was $120 and now it's grown to $156? That makes some good sense to me. The bar is longer. I'm looking for an increase. So I think we're going to answer here $156 this month. And maybe it would be impressive if I wrote a whole sentence. So I might say, Anna makes $150 this month. Final answer. Notice we use percent proportion. It would be very difficult to use this fraction to percent method because I don't have both quantities when I start. Now someone else out there might say, oh, I didn't use the 130%. I just figured out this 30% sitting back here. Maybe they just figured out this tiny chunk, this portion sitting right here. Well, when you get that number, I know you're going to have to add it on to 120 or onto the original. So it looks to me like you'd have 120 as your original number of dowels. You are going to find that there are 36 more dowels. Oops, I probably should just write more here. 36 more in the second month of making dowels, which will get you the same great answer. Okay, so maybe you went about this a little bit differently, but you still tried percent proportion. You just used 30% instead of the total 130. That's okay. Let's move ahead here and take a look at number 2. We're still talking about percent change. And I know with a quick skim, if I just grab the number values really fast, I notice that neither one of these are a percent. It looks like I have two quantities. Hint, hint, wink, wink. If I want to use a different strategy, I could go from fraction to percent on this one, because I have numbers or quantities that could be written as a fraction most likely. Let's go ahead and read. Number 2. Last year Chantel bought a car for $24,000. The current value of the car is $21,000. Find the percent decrease in the value of the car. I'm going to point out here, we're trying to find a percent and a decrease. And sometimes they'll just ask you how much did something decrease, but in this case they want a percent decrease. So the decreased percent is what I'm shooting for. Well, I will walk you through this second strategy because I do again have two quantities. And if you notice in your notes, what we said is we're looking for the change or the difference over the original. So to translate that, the change would be the 24,000, take away 21,000. And somebody would say, oh, but in our notes you did the smaller number, take away the larger number, and had to deal with absolute value and a negative. And while that is all true, this will absolutely work as long as I tune into this idea of a decrease. I'll be okay. All right? And this will go over the original amount. So the original value of the car was $24,000. We're really ready to simplify this fraction. So if you look at this subtraction, 24,000 take away 21,000, I get 3,000 in the numerator. And my denominator has not changed. You might notice that we could simplify. Both of these divide by 3,000. Well, 3,000 goes into 3,000 one time, and 3,000 goes into 24,000 8 times. I get 1/8. Well, really now I have a fraction and I'm trying to turn it into a percent. So any fraction to percent can happen by multiplying by 100%. Be careful, this is written over 1, not over 100. Okay, we're turning it into a percent, and we multiply by a value of 1 or 100% in the numerator. You might notice that there's some cross-simplifying we could do. I noticed that 8 and 100 both divide by 4. 4 goes into 125 times, and 4 goes into 8 twice. If you go ahead and multiply across, 1 times 25 is 25, and 2 times 1 is 2. And this percent sign is still here. It hasn't simplified. Good, I'm sitting here looking at a percentage. It looks pretty nice, except that it is improper. So your next step would be to divide the numerator by the denominator. You're going to end up with a mixed number, and that's going to help us to answer the question. We're finding the percent decrease in the value of the car. So I'll get you started on the sentence. The car depreciated. That means that it decreased. I don't know if depreciated has 2 P's. Depreciated, I think I'm okay. By blank percent. And maybe you don't use the word depreciated. Maybe you write the car's value decreased by a certain amount. Okay? If you are working with those negatives and you're thinking about absolute value, that negative is happening in there just because it's a decrease. That's why you're seeing that. So if you decided to swap the order here, you'll still get to a fine answer. You just really want to tune into that idea that this was a decrease. Let's take a look at number 3. I kind of hope that I didn't spell depreciated wrong for the whole world, but that's okay. If you're watching me on YouTube, you know I'm a math teacher, not a spelling goddess. Number 3. It costs Carrie $400 to build a treehouse. He sells the treehouse to Nanette and makes a 48% profit. How much does Nanette pay for the treehouse? I noticed a couple of things. I see a cost. This is kind of like the original cost. I didn't label that really well in the other ones, but here I see an original cost of a treehouse. And it's also a quantity. The quantity is the original amount paid. Next it says Nanette. Nanette is making a profit. Ooh, this is an important word, key word. A profit is an increase, right? So this is increasing by 48%. It's kind of the American way. I make something for $1 and sell it for $5. Oh yeah, I'm making money now. Okay, so same idea here with the treehouse. Nanette is hoping to make some money. Well, notice this is a percentage. So this is a percent increase. I have a quantity and a percent. Already a hint to myself. I probably want to use percent proportion. So let's go ahead and get our 2 fractions set up. Let's be careful about that. You hopefully remember in percent proportion, there's a number that will always remain the same, and it is the 100 in the second denominator, the second fraction, the lower level. Bam, 100. Well, this 48% is a profit, and I do want to look at that in a second. But I noticed this $400, the original quantity. The original, if you look at your flip book, tells you that the original quantity goes in the bottom of the first fraction. So it's my denominator of the first fraction. I might show this percent sign over here just so that you notice our quantities are always going to align on the left and our percents are always going to align on the right. It would be really fast for me to plug in this 48. It's not wrong to do that and put your unknown cost, or how much does the net pay for the treehouse. It would be okay to put the unknown here, no matter which way we decide to do this, and you could quickly put 48 here and it would work. But again, if you break this down into a bar model, you're picturing the entire bar. That's the whole treehouse, 100% of it. That cost $400 to make. But when you go to sell this, actually it's Carrie that's making the profit, isn't it? Carrie wants to make a 48% profit. So I'm going to kind of extend this bar for you, and I'm going to show you that this little chunk here is a 48% increase. Well, what are they asking me to find? How much more did Nanette get charged? Or how much more did Carrie charge Nanette? Or how much does Nanette pay? Oh, what Nanette pays is actually talking about a total. So this is similar to the last one we saw, where I might actually draw my bracket here to represent this entire distance, this entire length, the 100% plus the 48 more. Oh, that's the same as 148%. And in a minute, I'm going to try to find the unknown quantity, how much X is worth. So again, another way of seeing this is to take that 48% and record it as 148%, because I don't want just the whole treehouse. I want the whole treehouse plus its increase, plus its profit. If you remember, our next step in our notes when it comes to percent proportion, so I'm referring to the other day, percent proportion tells you to check the left fraction, see if you can simplify. If not, check the right fraction, see if you can simplify, and the answer is yes, you can. But I noticed something. If I do simplify this 100, which looks pretty friendly, is going to be broken up a bit. I'm not sure that that's bad, but I don't mind dividing by 100. How about you? What would happen if I left this alone? It's just another way of seeing things. It's not right or wrong to simplify here, but some of you are scared of these big numbers, so in that case you would want to simplify. This isn't bothering me so much because I like 100 times x gets me 100x. That's a pretty nice thing to work with. Next I'm going to cross products, multiplying diagonally. And I'm going to walk through this. I know I'm going to have a couple of zeros at the back because I have 400. 4 times 8 is 32. I'll keep the 2. Regroup the 3. 4 times 4 is 16, plus 3 more is 19. Keep the 9, regroup the 1. 4 times 1 is 4, plus 1 more is 5. I should get 59,200. Well, remember, I have my cross products set equal to each other. This looks really nice, but I currently have 100 variables, 100 kings. How confusing. Let's get this variable alone. In order to undo the multiplication that's happening here, we divide. We divide by 100. If I divide the left by 100, you must divide the right by 100. I hope you're noticing that this is going to make a decimal move twice towards the left. X in this case, because remember these simplify to one whole x or one whole king, okay, and I can show that just with an x, will get me 592. I found the total. This 592 really belongs over here. And if you remember, we were measuring in dollars. Let's go ahead and try to make this a final answer. So, how much does Nanette pay? Nanette pays $592 for the treehouse. A follow-up question might be, well, how much was the percent increase? Okay, or the percent increase was equal to how many dollars, or how much more did Carrie charge? If it's asking for just that piece, I could definitely do a quick comparison here. I could look at my original, my 400, compared to my 592, and I would know there's a difference of $192. That makes pretty good sense to me because 48% is pretty close to 50%, isn't it? And half is the same as 50%. Half of 400 is really close to 200. So just kind of thinking out loud here that I think this is a reasonable answer. It looks to me like Nanette's going to pay $592. Let's take a look at number 4. Here it says, of the 280 granola bars that a bakery produces daily, 40% have nuts. How many more nut bars must the bakery produce so that the number of nut bars will increase by 25%? So here I'm looking at 280 granola bars. Sounds like that's the original, or the total. That's a quantity, isn't it? And over here I notice that they have 40% listed as having nuts. So this is a percentage. Okay. I'm not sure where I want to head with this yet because I see a second percent coming right about here. So there's another percent listed. I'm feeling like there's so much information in this problem at this moment that it might be really good to visualize it. So let's give it a try. What could we say the whole bar always represents? 100%. And in this case, the 100% is the same as the original or the total. Well, it's the same as the 280 granola bars, isn't it? This 40% I can deal with because it says 40% of those total have nuts. So I'm going to look at this bar and I know 40% is a little less than half, maybe right about here, and I'm going to label this 40%. Oops, I wrote 4% by accident, sorry. We can fix that. Good thing you're working in pencil at home. 40% represents those with nuts, okay? Well, now it goes on to say how many more nut bars must the bakery produce? So how many more must they produce? So I'm going to kind of highlight this. How many more nut bars? I'm trying to find the amount of increase. And then it goes on to say, so that will increase by 25%. Well, let's do this first. Do we know how many nut bars are sitting here? Do we know this amount yet? Not really. And in a minute, if I can find that, then I could definitely show you an amount to increase it by. I think I'm going to start right here, and I'm going to save this 25% increase for in a little bit, okay? So let's go ahead with our bar, nope, we already have a bar model, with our percent proportion. I know that the whole thing, the whole bar represents 200 bars, and that represents 100%. On the other side here, I know that 40% really belongs to the unknown number of nut bars. Well, I see some simplifying we can do. Maybe not on the left, but on the right, these both divide by 20. 20 goes in here twice, and 20 goes in here 5 times. And those percent signs, if you notice, will also simplify, which is good, because I don't want a percent. I want to find out how many nut bars there are right now. Well, if I take a look, I could do cross products next, and cross products this way also. I know that x times 5 is the same as 5x. And I know that 2 times 280 is the same as 560. 28 doubled is 56, put a 0 behind it. And I need to get this variable alone. I need to isolate the king or isolate the variable. So I'm going to divide both sides by 5. I'm going to undo the multiplication that's happening here with some division. Well, when I go ahead and divide, this simplifies. This gets me 1 whole king, which oftentimes I just show with an x all by itself. On the other side, I know 5 goes into 500 one time here, or actually 100 times, and 5 goes into this 60 one time with 10 left over, so looks like I'm going to get 112. Maybe you want to do the long division and try to get there also, but it looks to me like I found there are currently 112 nut bars. That's this unknown piece. This is actually 112. That makes good sense to me because 280 was the total, and 40% is slightly less than half. And I know half of 280 is 140. This is slightly less than 140. This looks really good. But do you remember that they wanted to increase these? They wanted to increase this by 25%. They want to find out, oops, actually, I put that bracket in the wrong spot, because they only want to find out how many more bars they have to make. This is my next unknown. This tiny little piece that shows an increase, okay, a 25% increase is what I'm going to deal with next. Well, there are a couple ways of doing that, but because I have a quantity, my 112 bars, and I have a percent, the 25%, which I was saving for later, I can use it now. I know that a percent proportion would probably work a second time. Okay? Are there other ways to get there? Could I absolutely take 25% and write it as a decimal, and then multiply it times the quantity, and then add it on? I could. There are other ways to get there. But let's talk about this percent proportion. I almost guarantee that it works for most problems, so let's give it a try. 100 always goes in the bottom right of my second fraction. The 112 is actually the total number of nut bars originally, so that becomes my new denominator. We had trouble with a problem like this the other night. I had some students ask me, was that problem about girls and boys or teachers and students, and somehow we had to change from talking about the total number of bars, 280, to just the nut bars. So that denominator is changing. Well, I'm still trying to figure out how much this increase represents, what quantity goes with it, but I'm making a 25% increase. And I might point out here that I'm not going to add that 25 to the 40, because they don't ask me how many bars altogether need to be nut bars. They ask me how many more. They're asking me just for the number that represents the change. Well, looking at my fraction here on the right, I see I can simplify. 25 and 100 become 1/4, or 1/4. There's cross products possible here with 4 times x, and it'll get you 4x, and 1 times 112 gets you 112. To isolate the variable, we're going to divide both sides, and we better divide by 4. So we'll give this a try. Well, I know 4 goes into 125 times, and 4 goes into 12 3 times. So I lost track of what I said there. 4 goes into 125 times, and 4 goes into 12 3 times. 25 plus 3 is 28. We should find out that there are 28. 28 bars. That's what belongs here. 28 nut bars. Okay, so if I were to fill this back in on my bar model, it's kind of this chunk sitting here. It's the increase. I had the percent increase, but I needed the number or the quantity increase. So the next thing you need to do is give me a final answer. This final answer probably needs to be a nice sentence because I've been doing better with that this evening. So I might say, how many more bars? How about the bakery produces 28 more nut bars. All right. We're done with 1 through 4. That is the front page. That might be the initial assignment that some of my classes have received. I am going to take a look at maybe just another problem or two on the back side, because maybe you're feeling like you haven't had enough practice with this yet. So I am going to carry on. Doesn't mean that you have to, not if it has not been assigned, but it's always better to do more than not enough. So I want to make sure that you are prepared if a question like any of these appear on the test. So this change idea, it's not the primary focus of our test that's upcoming, but it is something that will happen. You will probably see something similar. I just want you to be prepared. Number 5, Samantha had 75 necklaces to sell. By the end of the first week, there was only 57 necklaces left. By the end of the second week, there was only 38 necklaces left. Find the percent decrease in the number of necklaces by the end of the first week. Okay, in part B, find the percent decrease in the number of necklaces from the end of the first week to the end of the second week. I like this one because they're asking some follow-up questions, and oftentimes if there are multiple parts, you want to make sure that you get full credit, especially when we're approaching a test soon. So multiple parts means multiple points. Well, I see here that we have 75 necklaces. Sam had 75 necklaces to sell. This is the original quantity. By the end of the first week, there was only 57 necklaces left. Oh, this is still a quantity, but this is a new quantity, okay? And I noticed that it also decreased somehow. By the end of the second week, there was only 38 necklaces left. Oh, she's having good luck selling these necklaces, right? So this is the last quantity, maybe, and we would say that it's still decreasing. Let's find the percent decrease in the number of necklaces by the end of the first week. So here we're talking about just the first week. I like this problem because it's going to show you again how we can maybe use two quantities to turn our change into a percent. So if you look back at your flip book, you know that it says something like change or maybe difference over the original. And in a minute, if we can set that up, we can turn any fraction into a percent. All right. Well, the change, that's like saying I had 75 necklaces, but I sold some, right? I'm left with only 57. So I need to figure out what the change was, and I'm going to write that over the original number of necklaces, over the 75. Well, let's simplify this a little bit. You have a little bit of a regroup maybe. Let's see, 75 take away 50 would be 25, and 25 take away 7 looks like it would get me 18. So I just want to double check that, but I think 18 is going to work. So 8 plus 7 is 15, regroup that one. 8 and 1 and 1, yes, 8 plus 1 is that 7. We're good. I have 18 over the original 75. Looks okay to me. Well, if you remember, with any fraction on the planet, if I want to turn it into a percent, I can take that fraction and do what? Multiply it by 100%. Over what? Not over 100. Most popular wrong answer, over 1. We treat that 100% like a whole number, so every whole number gets a denominator of 1. Oh, I noticed something right about here. I can cross simplify. There's something that divides nicely into 75 and 100. It is, 5 is nice, that's true. But what about 25? Oh, 25 is awesome because it goes in here 4 times and it goes in here 3 times. Notice this percent sign, it's not cross simplifying or simplifying with anything, so it's still there. You might want to tune into that. I think we're ready to, oh, I was going to multiply across, but I see something else. Take a look at this 18 and this 3. Is there a way that these could simplify? Oh, yeah, they both divide by 3. 3 goes in here 6 times and 3 goes in here once. Well, now I'm really ready to multiply straight across, and I know 6 times 4% gets me 24%, and in my denominator, 1 times 1 gets me 1. Oh my gosh, there is a 24% something. Well, go back and let's dig into this question. Find the percent decrease. Oh, percent decrease is the question. So what percentage is this declining? So there's a 24% decrease in the number of necklaces sold in the first week. We would really want to follow the same idea for this next one. But notice that it says the percent decrease in the number of necklaces from the end of the first week to the end of the second week. So you're going to be using some different information. The end of the first week, end of the first week, end of the second week. Well, what number belongs with the end of the first week? End of the first week, 57. End of the second week, oh, 38. So this time when you go to set up your change, if you're going to follow the same strategy, your change is going to represent those two numbers instead. 57 take away 38. And I should also point out that here you're talking about the change from this original number, from the 57. So we're not going back and using the original 75, are we? We're just talking about the percent change from week 1 to week 2. So you would do some simplifying here, turn this into a nice fraction, turn it into a percent by multiplying by 100% over 1, and you'll be heading in the right direction. And you'll talk about percent decrease when you're done. I think this is a good spot to stop with our word problems. There are definitely a few more in here that I think are challenging and nice. If you decide to move on, I think I found here in part B, there is a 33 1/3% decrease from week 1 to week 2, or the end of week 1 to week 2. Number 6, if I look ahead here at what I did, I see that there is an increase of 44% in the area that they're asking for. And number 7, you'll find that there's a total of 258 fruits. 258 fruits were sold the next afternoon. So if you're sneaking ahead and you're just hoping for answers to see if things are checking out, that might help you. I hope that watching my video kind of walked you through some steps. I hope that if we assign the front page that you're in a good spot, that you would be able to tackle these problems on your own, or maybe even pause my video, you did it yourself, and then you just went back to see, oh, did I end up with the right result? If you did, we know things are going well for you. If not, you might want to take a closer look at the back side of this page and get yourself ready.